Okay, welcome back to the problem solving with this is now the dimensional analysis portion. Problem solving, part two. So here we go with kind of a new problem, and this is getting more into the type of problem solving strategy that you'll use for quite a number of problems. It's probably the most versatile problem solving strategy in all of mathematics is using dimensional analysis. It's throughout chemistry and physics, it's just everywhere. So anyway, in a certain gear of a bike, the ratio of pedal revolutions to wheel revolutions is 13 to 23. I'm going to stop right there. Pedal revolutions to wheel revolutions, and it says it's 13 to 23. So since it mentions pedal revolutions first here and wheel revolutions second, that means the 13 goes with the pedal revolutions and the 23 is the wheel revolutions, because the order that they come in a ratio is crucially very, very important. Okay, so it says if the biker pedals at a rate of 80 revolutions per minute, so this is the pedaling. They pedal at 80 revolutions per minute. So how fast is the wheel revolving? The wheel revolving in revolutions per minute. So we have this 13 pedal revolutions for every 23 wheel revolutions as a ratio. And that should be equal to, we should have pedaling revolutions up here and wheel revolutions down here. And it tells us that pedaling is at 80 revolutions for every 80 revolutions, and this is in a minute, right? This will be 80 revolutions per minute. This will give us the same x revolutions per minute, really here, right? Revolutions per minute and revolutions per minute. And so how do we solve for x? We cross multiply 80 and 23 and divide by 13. So x, which is, now this is wheel revolutions per minute, is going to equal 23 times 80 over 13. And I'm just going to write wheel revolutions per minute. Actually, I'm just going to write revolutions, because we know we're going to be talking about the wheel. So that's just simple. Now notice this is a proportion, right? Here we used a proportion. We went to an equal sign. And so let's calculate that. 23 times 80 divided by 13. And that is, I'm getting 141.538. I'm getting a whole bunch of numbers out there. And that's going to be revolutions per minute, and that's for the wheel. Okay? So, I think that's what it asks for, the wheel revolutions per minute. Now, you could have, here's another way you could have done it. If you have 13 pedal revolutions, 13, I keep making an R there, pedal revolutions compared to 23 wheel revolutions. If you used a unit ratio multiplier, we would have put pedal revolutions would have had to go down here, and we would have, right, we would have put pedal revolutions here. Oh no, we want wheel revolutions, so we'd have to put 23 wheel revolutions up here because we want wheel revolutions per minute in the end. We'd have to put 13 pedal revolutions down here, and we multiply pedal revolutions. If you multiplied, then they have to be diagonal to one another, and so that would be the 80 per minute, and this would be just over 1. So the pedal revolutions would reduce. You'd still multiply 23 times 80 over 13. So that's how you do that. But anyway, it's 141.538. Now let's take a look. I'll just write that 141.538 wheel revolutions per minute. And we can just talk about revolutions per minute because this isn't going to talk about the pedals anymore anyway. So it asks now, how fast is the bike traveling given the diameter of the wheel is 27 inches, and in one revolution, the bike will travel the distance of one circumference of the wheel. Okay, it says write your answer in miles per hour. So we want our answer over here to be miles per hour. Okay, so miles over hours. So that means we want, notice this is the distance in the numerator and a time in the denominator. And what do we start out with? We start out with 141.53, I'll just round that off, 141.538. Now, if I think of that as revolutions per minute, right, then you have revolutions over 1 minute, and that has at least time in the denominator, so I know I'm kind of on the right track there, because time is a lot. Now, what do I have to do? I have to change revolutions, wheel revolutions, to miles, and that's the trick on this. Now, this is going to be pretty, it's kind of a cool puzzle. How do you get rid of revolutions? Well, we better have, now these are wheel revolutions, so we better have a revolution down here in order for this to be reduced out. Now, it tells us, this is pretty crucial, in one revolution, that means it tells us one revolution, the bike will travel how far? One circumference of the wheel. So circumference is pi times diameter. So that's pi times, and it tells us the diameter is 27 inches. So one revolution is one circumference, and it tells us here the circumference you put in is pi times the diameter, and it tells us the diameter there. And notice what's going to happen. We're going to change revolutions, we'll reduce, right? And we're going to get inches. Now we're closer. We have to change inches to miles. So we've got to get rid of inches. We put inches down here. And I don't know how many inches in a mile, but I do know there's 12 inches in a foot. And this tells me that there are 5,280 feet in 1 mile. So that means I can reduce out my inches and reduce out my feet, right? Because I got to have feet to feet. And now minutes is not in hours, so what do I have to do here? To get rid of minutes in the denominator, I have to have minutes up here. And to get hours in the denominator, so I put 60 minutes and 1 hour. And there, I've completely done this one problem with all dimensional analysis. Those 3 things, just paying attention to what's going on. So now I have to do all this multiplication, right? This number times this number times, of course, 1, 1, and 60. The ones are pretty simple. This is 1 times 12 times 5280. So I'm going to multiply all those numerators numbers. And remember, pi, you can use 3.14 for pi if you want. Or again, I showed you how to do that on the calculator. So I'm going to take that 141. I'm going to go times pi on my calculator. And then times 60. And that'll give me a pretty big number, 26,679. And then I'm going to divide it. So I'll just write it down here, 26,679.37. And I'm going to divide that by this denominator, 12 times 5280. Now, normally I would take all this, I'd put all these numerators, I'd put those in parentheses up there, I'd put the product of the denominator in parentheses and do it all in one fell swoop. And I usually don't do this intermediary step. But anyway, we've got it there, 26,679.37, 26,679.37. Something's wrong with that picture. Oh, I forgot to multiply by 27. This number is mistaken. I left out my 27. This was 720,342.99. And now I'm going to divide that by the 63360. And that gives me 11.369. So it's about 11.4 miles per hour, or 11.4 mph. That's the average speed, or the approximated speed if you're pedaling at 80 revolutions per minute, which is a pretty normal speed for biking. Might be a little fast for some people. Okay, number 8. A certain pesticide is sold in 10-pound bags, which cost $65 per bag and will cover 50 acres. How much will it cost to buy enough pesticide to cover a field that is 1,600 feet by 1,600 feet if you have to buy the pesticide in full 10-pound bags? And then it asks, what is the value of the pesticide that you will actually have to use? Okay, so we'll probably end up buying more than we have to use because you're only supposed to use 10 pounds for 50 acres, right? So that means it'll cost you $65 to cover 50 acres. And how much do we have? How many acres of land do we have? Well, it says we have 1,600 feet by 1,600 feet. And it tells us down here that 1 acre is 43,560 square feet. Notice this is in square feet. So we got square feet down here. And this just gives us a length and a width, which is square. So the area, this is an area, right, when it's in square feet. So we have to find the area of the field. And the area of the field it's a square field, so it's S squared, or length times width, which when they're the same, we usually write it as S squared. And so that's 1,600 squared, basically, right? So 1,600 squared, you can do that on your calculator. That's 256 with 4 right, 1, 2, 3, 4. 1, 2, 3, 4 zeros. And that is square feet. So that's the area of the field in square footage. But notice the bag is, the $65 bag covers 50 acres. So let's change this to acres and see how many acres we have. So this is 250, actually 2,560,000 square feet. And to convert that, we're going to change, we got to have square feet down here, right? So we have 43,560, and that's 1 acre. So basically we're going to take that 2,560,000 and divide it by 43,560. And that is about 58.7695 acres. So about 59 acres. Now, if one bag covers 50 acres, you're going to have to buy a second bag because it won't be enough. So you're going to need, you will need, right, 2 bags at $65 per bag. So that's going to be $130 that it'll cost you, okay? To buy the pesticide. Now you're not going to use all of it. Okay, you can't, if you don't use it all, then, now a lot of times they don't let you buy more than you need. It depends on the pesticide. But it's $130, but you're not going to use all of it because you only need 58.7695. You only have this many acres. Now, if it tells you that for money, if you want to find the money, it's $65 to cover per 50 acres. And so we start out with, you can use a proportion. You can say how many dollars would that be, X dollars for 58.7695 acres, right? You've got dollars to acres and dollars to acres. So you can just multiply 65 times, right? You cross multiply and divide. 65 times the 58.795 and divide that by 50. And that gives us $76.40 approximately. So that's what it would cost if you just did just for your expenses for that one, for your acreage. So you'd have what, 50 bucks worth of pesticide that you're not using. Okay, next let's take a look at the last problem. Consider the cost of gas to be $2.89 a gallon, and you drive a vehicle that gets approximately 24 miles per gallon. You also figure that wear and tear on the vehicle costs about 18 cents per mile. So now here's some basic facts. Now, how much will it cost in gas to take a vacation and travel to a destination 350 miles away and then return? So just in general, if you're making a round trip, you're going to have to double the mileage each time. And a lot of people don't calculate that on some of these problems. They think, well, I just have to get there, but it's a round trip most of the time. I think we did something similar with the gravel. Oh, in the next video, we'll do something similar with the cost of gravel. So here's of hauling gravel. But this is $2.89 per gallon, and your vehicle gets 24 miles per gallon. And now you're going to go 350 miles and then come back. So basically, you're going to go 700 miles, right? You're going to times that by 2. So 700 miles. I'm going to convert miles, how many miles, into how many dollars that's going to cost. Now, if I start out with 700 miles, then I know to convert that to dollars, to change the distance to dollars, I've got to have miles in the denominator, don't I? And the only thing that tells me about miles is this 24. 24 miles per gallon. We usually write it like that. But that's the same as 1 gallon getting you 24 miles. So we usually put the 1 gallon up here and the 24 miles down here when we use it to do this calculation. In other words, if you're going 700 miles, if you divide it by 24 miles, that'll tell you how many gallons you get. You know, at the same time, we can put in dollars. Now that'll get rid of miles, right, and give us gallons. At the same time, we can put in this $2.89 per gallon, puts it over gallons, and that gives us the conversion of, we had miles, this converts miles to gallons, and this converts gallons to dollars. And so we get 700 times 289 all divided by 24. So we can do that in one fell swoop. I'm getting $84.29 and some little odd change there. So next, now let's just make it clear. We could have just stopped here and said how many gallons it would take, right? If you get 24 miles per gallon and you got to go 700 miles, you could just divide 700 by 24 and get gallons, and then multiply that by 289. I just did it in one nice big fell swoop. And now it says, what will the total of gas and wear and tear cost for the trip? So this was just, let's notate that, that's just gas. So to get the total, we still have to do wear and tear, which is what? 18 cents per mile. So if that's 18 cents per mile over miles, we multiply that by the 700 miles. Our miles drops out, and we get 700, right, times 0.18. That is $126. That's a lot more than your gas, isn't it? But you have to, for the total, we'll have to combine those. So you add the 84.29 to 126. Should be 210, yeah, that should be 210. Equals $210.29. Okay, so this is a pretty important problem. This comes up, how to calculate how much your gas cost is going to come up in several other problems, and in one of them you have wear and tear also, but most of them are just gas. Anyway, that is all for the lesson number 2 on dimensional analysis and proportions. Okay, I hope that this is helpful. Good luck.